tries to actually be productive and post something during summer break the day before school starts. Yay! So let me give you some background knowledge. So when school starts, which is tomorrow, I'm taking pre-calculus, and I thought, hey, I'm kind of not doing very good at math, and so I'm gonna preview because I'm just so amazing. And then I'm like, okay, I'm just gonna start doing calculus. And then I start doing calculus, and then I realized that pre-calculus and calculus isn't the same thing. But anyways, that's not about my trauma. I have a better filming setup now. I'm not filming on a Zuka, but I'm still sitting on the floor. Whatever. So today, our lesson will be on integration, okay? So integration is when you take x, which is our variable, and then take it's originally to the nth power, okay? It's originally to the nth power, but we're gonna make it into x to the n plus 1 power divided by n plus 1, okay? Oh my god, there's like a reflection. Who cares? That, okay? So that's just the basic thing you need to know about integration. So let's get right into the scary problems that I'm going to show you how to solve. So this is the question, and I'm going to read it because that's how things work around here. So ask to evaluate this disgusting equation. Okay, so let's write it down. Integration symbol 2, -2, x absolute value plus e to the absolute value plus x to the 5 power dx. We're asked to evaluate this, okay? So what we need to know is that these two numbers are the range. It's from a range from -2 to 2. And then we also need to know another theorem or the principle, whatever you call it, that when, let's say I have an integration symbol, and then from -1 to 1, and then this can be broken into two parts which has a range from 0 to 1 and a range from -1 to 0. If you add whatever these two equations thingies are together, then we get the answer to the problem, which is -1 to 1. Okay, so that is the thing you need to know here. The complicated part about this problem is that we have an absolute value here and to the power of e. And so what we can do is to break this function into two parts when ranging from -2 to 0 and from 0 to 2. Okay, so let's break it. Okay, so we have integration symbol -2 to 0, and then since x is going to be negative at this point, so we're going to have -x. Okay, integration symbol -x, and then we're going to plus integration symbol -2 0. So this is going to be e to the -x again. Okay, but this has no absolute value symbol, so we don't actually have to break it into two parts. So I'm just gonna write down when integration symbol from 0 to 2. 0 to 2, x, dx. And then plus integration symbol 0 to 2. And then e to the x. And then plus integration symbol -2 to 2. X to the 5th power. Okay, so this is our equation. But keep in mind, there is a condition. Actually, there is no condition. I'm sorry. That's our next problem. So let's continue doing this. So we know, as I said earlier, we need to take x to the n plus 1 power divided by the n plus 1. So we know that the integration of negative x is going to be negative x squared divided by 2. Okay? And then we know that this is going to be, this is a little bit complicated, so let me just write it down. Give me a second. Let me use the power of editing. Boom. I just made everything a little bit smaller so we can write. Yeah, okay? So we were gonna do integration on e to the negative x. Okay? And so we're just gonna write that down here. Okay, so this is a little bit hard to do integration on. And we can't do it like directly because, yeah. But what we can do is I make another variable. I say let z equal to negative x, okay? So this becomes e to the z dx. But I still can't do integration on this because this is dx, but my variable right now is z. So what I can do is write dz dz multiplied by dx divided by dz. It's the exact same thing, but I just added multiplied by dz and divided by dz. That's it. So we can do integration on this, but we need to multiply by dx over dz. But what even is this thing? But we know that dz divided by dx is the derivative of dx of z, and we know that since z is equal to negative x, we know that means my brain is not working today. It's -1. Yes, -1. And then dx over dz is just going to be the reciprocal of -1, which is still -1. So, and we actually do know the integration of e to the x. That's like a formula thing that you need to remember. It's just e to the x. So since our variable is z now, and we have dz here, then it's going to be e to the z, and then multiply by -1. And then we just put x back in there, which is -x. And then that is our answer for the integration of this part. And now, I'm just gonna first write it down here, okay? We will plug in the values later. So, yeah. I'm just gonna write down the solutions we get. Now, we're going to do integration for x and e to the x. And that's actually pretty simple. We know that x integration is equal to x squared divided by 2. And then this is going to be e to the x. And then we know the derivative of x to the 5th power is x to the 6th power divided by 6. So we have 1, 2, 3, 4, 5 integration things. So now all we have to do is to plug in the ranges for the corresponding integration. So for this one, if we plug in 0, that's going to be 0. And the minus, if we plug in -2, that's going to be minus, which is 4 divided by 2, which is 2, so -2. So this is going to be equal to 2. And then we do the same thing for minus e to the negative x. So when x is equal to 0, then this function is equal to -1, and we need to minus when x is equal to -2, which is -e squared. Okay, and then that is equal to -1 plus e squared. Okay, we're just gonna leave it there. And then we do the same thing with x squared divided by 2. But remember, this is a different range, so we need to plug in different values. So this is going to be 2 minus 0, which is equal to 2. And then this is going to be e squared minus 1. Okay? And then we plug in this, which is going to be 2 to the 6th power divided by 6. Oh God, my brain is not working today. Okay, so we have 2 times 2 times 2 times 2 times 2 times 2. 4. Okay, 64. Yeah, 64. 64 divided by 6. You know what? That was stupid. Why did I do that? Which is equal to 32 divided by 3. Yeah, we're just going to do it in fractions. Yay. So now all we have to do is to do 2 plus this, plus this, plus this. No, actually no. Yeah. So we need, and then for this value, we need to minus. We already plug in -2, which is the same thing. So this is equal to 0. So we don't need to count that. So we can actually remember from this that when we are plugging in the values which are like opposites of each other, like 2 and -2, and in this type of equation, this will definitely be equal to 0 because 6 is an even number. Hi, we had some technical difficulties. Anyways, we are back to the problem, okay? So after we found all of the values for the range in this entire thing, then all we have to do is to add it up. And so we have 2 plus 2 plus -1 plus e squared plus e squared minus 1. So if we add all of those up, we should get 2 plus 2e squared. And that is our final answer. So this may seem a very complicated, and yeah, it is. But basically all we're doing is, first step, we're breaking this into 2 parts. Like the ones with the absolute value, we're breaking it into 2 parts because the absolute values are different when it's negative or positive. And then what we do, we just find the integration values and then we just add them up. That's literally it. Yeah. So that's that. So now let's go to the second problem. Yay. I actually wanted to do 4 problems. Now looking at this video, it's like 10 minutes long. So like, okay. Okay, this is the question. So you can try it if you want, but I'm gonna say how to do it. Okay, so Act 2, evaluate this monstrosity of an equation. Okay, great. So pause the video. So let's write down the equation. Integration of 1, -1, absolute value of x plus e to the x plus cosine x derivative x. So here's the thing. You can do it the complicated way like I did last time. But for this question, actually, there's a simpler solution to do it. So if we look at it geometrically, this graph is symmetrical with the y-axis. And then this one is also symmetrical with the y-axis. And cosine x is also symmetrical with the y-axis. So, another thing, we can see from all the options that they all have 2 plus 2 sine 1. And we know that this 2 sine 1 can only come from the cosine part, because there's no way that an e thing is going to turn into a sine thing. So we actually don't even have to calculate this part. Yeah. So since this is symmetrical on the y-axis, now we know that the two things from -1 to 0 and 0 to 1, they are going to be exactly equal. So all we actually have to do is to do 2 multiplied by from 0 to 1, 0 to 1, x plus e to the x. That's literally all we have to do. So let's find it. That's x squared divided by 2 plus e to the x. Let me plug in this. So we get this is equal to half plus e, and then we need to minus, this is equal to 0 plus 1, minus 1, so minus 1. So we have half plus e minus 1, which is equal to e minus half. And then we multiply this by 2, so we get 2e minus 1. Booyah. And then, so we get 2e minus 1 and the plus 2 sine 1. And so, as we can see in the options, the only correct answer is B. See? We are so smart. Okay, so this video is going to be a long one. So let me see if we have time for another one. You know what? Sure. We're doing one more question. I decided to be stupid, and we're making editing Aaron do more work because now the board is clean. Anyways, exploration. This is the exploration. What are the derivatives of fx is equal to the integration symbol of from 0 to x 2t dt, and gx is equal to the integration of 0 to x 2 sine dt respectively? What patterns can we observe? Okay, so let's do it the proper way, because why not? Fx is equal to x from 0 to x 2t dt. Yeah. So that 2 does not look like a 2. So let's first do integration. We want to find the derivative of this thing. That's what it says. So we do the integration on 2t, which is equal to t squared, unfortunately. And then if we plug in x, we get x squared minus 0 squared, which is 0. And then if we do derivative on this, then we get 2x. So if we take a look at this, it is just equal to the original function, but we just plug in the x and 0. Let's see if this is the case for the next example, okay? So gx, let's do integration on gx. Gx is equal to integration of that to sine dt, okay? So sine t, sorry, didn't see that. So if we do integration and on this is actually equal to, I don't have these memorized, so just be quiet, okay? Negative cosine x, negative cosine t, so it's -2 cosine t. So that is the integration. If we plug in x, then we get -2 cosine x minus. And then if we plug in 0, we know that cosine 0 is equal to 1. So we get minus 2, which is plus 2. So this is what we get. And now we're going to do derivatives on this thing. So the derivative of cosine x. I got this, bro. Trust me. Okay, so the derivative of cosine is equal to negative sine x. Negative sine x. So since we need to multiply by -2, so we can just get rid of that negative sign, and we can just say 2x. And then plus, if we do derivative, that is gone. Okay, so again, we see this pattern. This is exactly the same as the original function if we plug in x and 0. Okay, no. And we can also see that if it starts, even if it starts from 0 or any number, it doesn't matter, because whatever coefficient at the end we have here is going to, we're going to destroy it with the derivatives. I sound insane. Okay, so we get the point. Okay, if it's x, it's gonna work. That's what I'm trying to say. Okay, this is gonna be our last question because I feel like this video is gonna be way too long if we do 2. So this is the question, ask 3. Now, find the derivative of the function gx is equal to 2x square root 1 plus t squared dt. Okay? Integration 2x1 square root 1 plus t squared dt. But here is the important part, the part that it makes this not easy. This has 2x here. Okay? So 2x is gonna make everything a lot harder, because we know that whatever we just figured out in the exploration is not true unless says it is from some number to x. Okay? Yes. So what we have to do, we have to get rid of it. And how do you get rid of it? Okay, so let's say I have another function and I have another variable called u is equal to t over 2. Okay, so remember, keep in mind that these two numbers are t is equal to t is equal to. Okay, so I have another function and I make it like this. Okay, so if we plug that in, this becomes x. Integration symbol from half to x, and then this becomes the square root, and remember t is equal to 2u now, so it's going to be 1 plus 4u squared d 2u. Okay, And so we can also like bring this 2 outside to play. Let's go outside to play. I wish I could do that right now. Anyways, so this becomes a lot simpler. So now all we have to do is to box it. Wait, but remember what we learned in the previous exploration thing. So we know that if this is x, then we can just plug it, plug it in, right? And it doesn't matter if what coefficient this is, because it's gonna be killed by the derivative. So the answer is 2 square root 1 plus 4x squared. Boom. That is the answer. Okay, this video is gonna be like really long. But yeah, so that's it for today. I hope you guys learned something. And I learned something too. I learned that I am stupid in the morning and my brain doesn't work and I hate myself. So have fun or don't. Also, good luck with school because for me, school is starting tomorrow. So adios, kids.